and the voltage is now up to 640. And now that it's up to speed, the current has gone back down. We're back under just under 4 milliamps, about 3 milliamps, and 680 volts. So it's leveled out. So this is the highest I've ever pushed it for is about 730. So what I'm going to do is put a heavy load on it and loosen it up a bit. There you go. That's really a very heavy load, and it's jumped to 8 milliamps and pulled the voltage down to 500 volts. But that is, you know, quite a heavy load. If that shaft wasn't covered in epoxy resin and a shining agent, that would have really burnt my hand. But as it stands, it doesn't. It actually slides quite well. It just feels odd from applying so much pressure with so fewer repercussions. So let's hope that remains the case when I up the voltage again. So I just gave it a fairly arbitrary twist and see what it picks up to. That's definitely breaking the record, coming up at 800 volts now. Current has leveled back down to 3.5 milliamps, and I'll have to be a bit careful doing this. There's a guillotine in front of me for timing, but I can. This one's got less torque. If I squeeze it basically as hard as I can, and I'll do that now, like. And fuck, a bit harder. Can I? No, I can't. So, but the current did shoot right up. The old one did that much more efficiently. So that went up to 23 milliamps, and the voltage would have dropped down quite a bit as well. So yeah, I'm not sure what the efficiency was on that, but we'll check it out. It's of dubiously low efficiency, this is my worst Newman motor yet, but that is somewhat intentional. I think we've lost a component. It's producing a strange buzzing sound. Yeah, that's interesting. Well, I'll turn it off before it does any more damage. But my next one is going to be heavier. The reason for this one to be worse is that it has higher resistance. I would have thought that would be better, but I wanted to prove that for sure. What matters more than the resistance in these motors is, of course, having it nice and tight, but critically, the weight of the copper. The drive coils have to be quite sizable. The bigger they are, the more of the magnetic field they can pick up. And that's why my first ever one was so effective. It had about twice the weight of copper on it. So this is still very good, very impressive. I'm going to fix this, or rather find out which transistor died under that heavy load, which is a bit surprising. That hasn't happened for a long time. Fix that and see if we can run a maximum voltage test to find out what the voltage can really go up. Good morning. Fancy seeing you. Well, I've just popped in to provide a bit of insight as to a limitation on the energy provided by science. Lenz's Law. Now, hello to my normal viewers. I won't be making a free energy machine today, but I will be talking about them. This is a video response to Daniel of Daniel's Inventions, and he's building a remarkable collection of machines, clearly aspiring to free energy. One of the models he's come up with is an Adams motor replication. There are quite a few out there, and they do not work. I would like to tell you why. Now, I've studied electronics for a year. I'm an engineer. Lenz's Law is known as the limiter. It's why a generator and motor cannot produce more than 100% efficiency. It is it's a bane of mankind, and if we did not have it, allegedly the world would be a much better place and we would have free energy. Now this is not true. This is what I was taught. This is what everybody says, and I have not heard a single counter to the argument of Lenz's law. Now, hats off. I love you deeply to all the men out there and women trying to beat Lenz's law, despite the textbooks telling us we can't. I'd like to share with you a solution that I have come up with that I feel much better about. I have decided, after 20 years in the free energy community, that Lenz's law is not a limitation, it is a regulation. It is a regulator. It does not limit the amount of energy in a circuit to 100%. It simply regulates energy. And I'd like to tell you why. And I spent a couple of days thinking about just how I'd explain this after watching Daniel's video on the Adams motor, because it looked like a great idea, and that was annoying to me because I knew it's not a good idea. I just had to work out how to explain why. So here we are. I'd like to tell you why this universal principle applies to all DC motors and a great deal more. So, and I really like to enjoy the process because the very notion I find alleviating and really helps my mental health and breaking through perceived barriers. So, to do this, I'm going to explain the difference with a normal motor and an Adams motor, and the motors that I have built, which seem very much to not only follow the guidelines laid down by every law imaginable, but also to produce considerably more energy than they should. So, I'd just like to show you what an Adams motor is, and it's difficult to hold the camera and do this at the same time, but I will try and be brief. In a word, I would represent a normal DC motor with this diagram. This is an electromagnet connected by a core, so you can use both the north and south pole of the electromagnet without wasting any energy. You're using all the energy in the electromagnet, and that will attract the magnets on the disc. Now, this is how a traditional normal DC motor works. I don't know exactly when they came to this breakthrough, but they used to be a lot less efficient. But Mr. Adams had a different way of using both the north and the south pole. So instead of simply connecting the core around the shell of the motor, what Mr. Adams did is have a electromagnet between two sets of wheels. Now, this sounds like it might be a good idea, and I love ideas. It's a good one. Whether it works or not is another story. So, what happens, right? Alright, time to get serious. A motor these days is built with an electromagnet. A magnet attracts to the electromagnet, and in doing so The electromagnet is turned on, which attracts the magnet, and then it's turned off and the magnet goes away. Now the bit that says go away makes almost no difference at all. There's a little bit of magnetism in the magnet and there's a little bit of iron in there, so when it goes away it pulls back a bit, so you lose a bit of efficiency there. You also lose a bit of efficiency in the copper coil, and you lose a bit of efficiency through the bearings of the motor. So the only bit that we're going to focus on is the bit that Lenz Law applies to, the bit that governs the attraction force while we're actually applying power. So a normal DC motor, 80% efficient. You might lose 20% through the magnets, the bearings, the coil, etc., etc. 20%. Okay, fine. These things happen. Now, if you're applying one, I got bees going around me. They're prolific. Holy shit! Just have a look at this. Oh my god! Okay, so if I duck at some point, you will know why. There are bees flying around everywhere. So, Lenz's law. This is what counts. Listen to this. Alright. An electromagnet by itself, with nothing happening, it's using 1 amp. If you have a magnet that is attracted to that, then the magnet itself induces electricity in the core. And that electricity in the core will reduce the amount of energy required by the power supply. So any normal motor, if you spin it up to full speed at the rated voltage, every time the magnet goes past the core, it induces a current, and that reduces the power required by the input. So this will be immediately apparent to anyone who's ever watched a DC motor go with a power meter on it. If you get a motor with no load, you turn it up to full speed, it will use a lot of power while it's accelerating, and then the power will go right down. It will be happy just running at full speed with very little input. That is the advantage of Lenz's law. Take out the magnet, throw it away, the power goes right up. If you leave the magnet and the shaft spinning, the power goes right down. So that is the advantage of Lenz's law. Alright, so we'll deal with the limitations later because they're down to geometry. The reason why motors don't exceed between 90 and 110% is geometry. So the reason why Adam's motor doesn't work is because designing this, a standard normal motor, to get 80-85% efficiency requires that the magnet approaches as the electromagnet at the right speed. So for that you need to adjust the power on the electromagnet. So you need to have the amount of wire perfect. It needs to be just the right number of turns and just the right thickness of wire. And that will define the voltage input and the current input, and that will define the rate of spin of the magnet. So if you can do that, that's good. But what you've also got to do, of course, when you're designing this like a normal electric motor, which is what you should buy instead, you've got to calculate the fact that that perfect speed of the magnet to reduce the current is contingent on having a set number of electromagnets around the circle and a set number of magnets. That's difficult to calculate even today, because that requires calculating the strength of the magnets also. It requires calculating the load on the shaft, and this is a large number of factors to bring into equilibrium. And if you put in too much voltage, or you don't take enough power off the shaft, or you take too much power off the shaft, the motor's going to lose equilibrium and it's going to drop in efficiency. DC motors are very good. They're impressive. They're highly efficient, but only in a very small band. They've got to get just the right amount of power and just the right speed and just the right load. Otherwise, the efficiency is very low. Now, these things are very difficult to calculate because there is a lot of variables. Now, the Adams motor, which is handmade by Daniel, who is frankly doing a great job. Now, normal factories have trouble getting a DC motor just right. They vary hugely motor to motor. Now, the problem is, with the Adams motor, you don't just have the wheel with magnets and the electromagnets. You have a second wheel, and what is great is you also have a third electromagnet. Sorry, a second and a third wheel. So you've literally got to put into equilibrium the and frankly, please don't consider how complicated this is to do, because it will hurt. In fact, yeah, I actually find it quite comical that people attempt to do this. But what I think is absolutely fantastic is some people get these Adams motors up to almost 50% efficiency, which is brilliant. Very impressive. That does, of course, render it fairly useless as a free energy machine, which is unfortunate because it took a long time to build and it was very expensive. Now, what really attracts a lot of people to these motors is an extremely appealing factor, which I'll tell you right now. So, in terms of a traditional motor, if you've got an electromagnet, and as normal, the magnet comes in, and due to the speed of the magnet coming in, reduces the voltage and reduces the input. So you've got an unloaded DC motor, and it's running at 80% efficient, which is really fantastic, and a lot more efficient than it would be if the electromagnet was just sitting by itself. So great, which is arguably very efficient on its own. So what people do that attracts them to the Adams motor is they switch the polarity of the electromagnet when it gets here, and then it pushes it away again. So it not only circumvents that loss in efficiency, it adds considerably more power, where it essentially doubles the power. Also, at, say, for example, 80% efficiency. Now, if you can do this, which is a fantastic idea, you gain a considerable advantage. But, of course, there is a problem. Because if the inward stroke gets reduced in power under no load, and you end up with an 80% efficient motor, then an additional 80% will give you a very powerful motor running very cheaply, and it will be disproportionate. It will be greater than that 80%. Consider this carefully. I'm not going to explain it in detail. This is what appeals to the Adams motor generation. What I will say is why this doesn't work. The numbers are arbitrary. This is why I will not do that exactly. So the reason why this doesn't work is because if you now propel the magnet away, then it will increase the speed of the magnet, and that will, all of them, and that will adjust the voltage induced in the electromagnet when it approaches, which will of course throw the entire system out of equilibrium. Now, this is a regulation problem, not a limitation problem. After all, if it was possible to use these principles to adjust a traditional electric motor, then people would. If all you had to do was flick an electromagnet and gain the additional speed and power on the stroke, then it would be done. It is not. Lenz Law is a renter. Now, before I go on, what I'm going to do in the rest of this video, now that I've explained exactly what Lenz's Law is and how it's applicable to the Adams motor and how the Adams motor principles cannot achieve free energy, I apologise for how simple this seems, because I know people have spent a while thinking about it, and I have too. In fact, quite a while. I've built a number of Bedini motors. They say that if you get any Bedini motors, you have an electromagnet, the magnet approaches, but you don't turn on the attraction until it gets right next to it. So you get the full power of the full attraction, bam, there, and then let it float away. This looks like a good idea in principle, because you're only powering up the system for a tiny little percentage of the rotation, and the most powerful percentage. So, if you get 80% efficient from that wasted energy, how much do you get from just right there? Well, the answer is much, much, much less. Much less. Bedini motors are only 10 to 20% efficient. This is due to Lenz Law. There is a massive advantage of Lenz's Law. It is highly useful. Now, Bedini motors are great. I recommend them for beginners. They're fun, but don't expect them to produce free energy, because I'm sorry, but they do not. They do not. Now, I built Newman motors, and I would like to explain them very briefly. They operate in a very distinctive Lenz Law fashion. Just briefly, before I go on to explain a free energy magnet motor, which I considered a day ago, and I've got the results of sitting there. The Newman motor will spin up at a very high speed and use 2 milliamps at 1000 volts or 2 milliamps at 100 volts. It doesn't matter, because the magnet is inside a very large coil, and because of that, it's always producing a high voltage. The magnets are always inducing a high voltage in the coil, so that is always reducing the input power, in line with Lenz Law, to almost nothing. So you can run a very large magnet and motor inside an even larger coil, and it will produce a lot of torque and consume almost no energy. And when you try to extract a bit of torque from that, it will do so without noticing. Now, just briefly, this motor here, if I was to turn it on, we have about almost 200 milliamps at around 5 volts. If I was to stop the motor, it's going to shoot up to 2 amps. And that is Lenz Law, because the magnets are approaching the stator and they can no longer produce energy in the coils, and the input power goes right up whilst the energy is producing no power. Now, in my Newman motors that I built, they will rotate very fast and very powerfully with a very large magnet and consume half that much power, despite being 20 times the weight and spinning 10 times faster and being handmade. Quite remarkable. Now, these traditional motors, these standard motors here, I explained to you how difficult they are to build to get one in equilibrium, and the only way they can do so is of course by designing for a specific power with a specific RPM and all the rest of it. It's a hideously complicated ordeal. Newman motors, however, will run at basically any RPM, any voltage, any input power, and be extremely efficient. Indeed, my tests show that they are well in excess of 100% efficient. So, but they're not alone. There are quite a few machines that do that. Lenz Law is not the limiting factor at all. That would be the geometry. So, if you can just hold with me a few more minutes, I'd like to explain a few systems that don't have Lenz Law as a factor, which makes them easier to exploit. Now, this is of course because they are simpler principles, and they are principles of free energy machines. Excuse me. So, one is something I was coming up with last week to assist a person in a magnet motor. They were trying to build a magnet motor that failed. They have a large amount of magnets spinning on a rotor and a succession of magnets around there, and the idea is that the magnets propel off each other and keep running indefinitely. This is the idea. People have been trying to do this a while, and there is a way of doing it. It can be done, but it's not very good, and it requires very specific measurements and build, and I haven't done it personally, but I believe it can be done, and I've seen it done. So this is not an avenue I'd recommend. What I suggested to this person is that they take a thin cylinder with a succession of magnets around it like that, and ordinarily one idea that comes up is if you've got two wheels, if you spin one, the other one will spin. These are magnets, they are magnetically tied to each other. What one does, the other does. So the input is connected to the output. If you want to apply 1 watt to the input, you will get 1 watt on the output. This is not good for a free energy system. There are a lot of ways to try and circumvent this, but most of them fail. There was one frankly smartass I met on YouTube who showed a magic box. This is a box made out of the cheapest MDF and wood screws you have ever seen, and allegedly perform the function of circumventing this rule. Action equals reaction. Now, I'm always skeptical of this naturally, and when you put it in a secret box surrounded by MDF, I am even more skeptical, because most people trying to flog their notions of free energy machines simply present them in a different way. But this guy was very confident, and very quietly pleased with himself. So I took the time to sit there for several hours and imagine what would be in that box, based on nothing really but the size of the box and the bearing positions mounted in the sides of the box and the angle of the output shaft. which is not a lot to go on. So I spent what is the best part of 2-3 hours sitting there staring into space, trying to imagine what this guy had in his box, with nothing but his smiley face to inspire my predictions. But I think I got it. In fact, if I didn't get it, I got something else. And this is what it is. So, what we would do instead is have a shaft, such as that. A shaft here. We mount a magnet on a shaft like that. And if we move this magnet across, it will repel this magnet here. Move this one across, this magnet gets pushed away. Right, now what's normally the problem with this is these magnets will repel each other. This wheel is at 90 degrees to this shaft here. So when you move this one across, the magnet on the wheel will be pushed and the magnet on the shaft will be pushed the other way, if it was indeed able to move. So because these magnets are 90 degrees to each other, as this one comes across, it will repel this one and this wheel. That wheel will spin and this magnet will come out the other side. The difference is, instead of the magnet on the shaft being repelled the other way, the magnet on the shaft will be held sturdy by the shaft itself. So as one gets pushed that way, one goes this way, and we were able to slide this magnet in very easily. This you can tell in about a couple of minutes flat if you have some fridge magnets and want to experiment. So, well done, Mr. Smartass. Thankfully I was able to sit there and waste 3 hours of my life dissecting the contents of his box, because now I'm able to share it. And I think this is rather clever. It is a concept that appears to work. Have not built it yet, don't need to. It quite clearly works. Of course it's not easy to build. There are a number of hurdles in the way, but what this represents is the input, which is the shaft sliding backwards and forwards, and the output, which is magnets going in this direction thusly. And if you can disconnect the input from the output, then you've got a motor that no longer needs to be confined to the law that says equal and opposite reaction necessarily in the literal sense. So 1 watt of input power would no longer have to equal to 1 watt of output power. This is quite a breakthrough. Why hasn't it been done yet on scale? Difficult to engineer, and there are a few idiosyncratics involved, but I'll leave that up to you. You can go have a play. What I'd like to do is demonstrate a different example of that, which I think is even cooler in a manner of speaking. If you want to figure out, if you want to hear about another free energy machine, I can explain this one in about 1 minute flat. This is of course a machine that produces more energy than it consumes, arguably very important. And hello Greta Thunberg, we have something to talk about. This will help. This is of course the Russian Milkovic oscillator. So how this works is, if you've ever been down to the park and pushed your child on a swing, you've got a pole for the swing up here, and the child swings backwards and forwards. Very easy to push the child backwards and forwards. They just keep on swinging. Just give them a tap. Just give them a tap and they just keep on swinging. The odd thing is, if you look up at the pole supporting them, it will be squeaking if it's made of metal, and if it's made of wood, it will be bending, and it is an enormously thick pole. This motion creates a great deal of pulling force on the object it's hanging from. And this is interesting because that little tap you're giving them is literally translating into the motion exhibited by an extremely thick solid object. So this is a mechanical amplifier, and it does produce more energy than it consumes. Various numbers have been gathered and viewed. People say it's 1,000% efficient, but not many people, because not many people go to working on. I built quite a large one. The weights were only 100 kilos, but it did produce well over 100% efficiency. And this is a fantastic example of a system where the input is not connected to the output. Once again, a Lenz Law free system. Fantastic. So you can build this one with complete impunity. Few hurdles has to be gained. Take 30 more seconds to tell you the problems just before you search into the Milkovic oscillator and waste too much of your time. Right, well, if you put a pivot point here and swing a pendulum backs and forwards there, that side will move a lot, not very much at all. You connect a generator to that side, you'll get a large amount of force while this pendulum is moving with very little energy input. The problem is, if the end of your shaft is moving up and down a lot, it will slow the pendulum down. It will actually slow the rate at which a pendulum swings, thereby wasting energy. What you do is you put it the other way around. So the pendulum is swinging like this, it barely moves up and down, and the momentum of the pendulum is maintained. This is how you increase the overall efficiency of the system. You have an extremely heavy pendulum, and you have a lighter weight on top of here to balance the shaft, and your generator connected here. I've built a number of different generators and kits to test this. Works very well. Water pumps, also not too bad. Quite a number of ways of doing it. So that's the Milkovic oscillator. Input disconnected from output. Brilliant. Proper free energy machine. Highly recommended. Overall though, I would suggest if you're an amateur, you would build a Newman motor. Check my videos. A lot of examples, a lot of builds. They're excellent. Now, there are quite a lot of other machines I'd recommend, but the last one I'd like to mention, I go so far as to mention, is a linear motor. I use this to power my Milkovic oscillator. You have a very large magnet on one side of a thick steel shaft, like a solid steel pole. Another magnet on the other side, and an electromagnet sliding in between. Now, to do the math on this, I used the electromagnet sliding between the two very large magnets, and I used the recommended math. Those bees are going nuts. There's some very simple math to calculate this. The electromagnet's energy is deemed to be equal to the rate at which it moves, which for example is 1 meter per second, times the pulling force the electromagnet produces, which is 100 grams, and 100 grams times 1 meter per second equals 1 watt. So that was pretty easy to calculate. That's perfectly mainstream energy calculation. 1 meter per second pulling a force of 100 grams equals 1 watt. Now this machine with a quad filer 5 ohm coil, was able to produce a force of 670 grams, tuned for 1 meter per second, and that consumed 1 watt. So at its best, 670% efficient, COP 6.7. This is also a good machine, but it is low powered, high weight and high cost, and the higher you turn up the power, the efficiency will reduce. For example, if you got it up to 20 watts, you would probably be down to about 100% efficiency. This is a shame. So not a great way to produce free energy, unless of course you're using it to drive a mechanical amplifier, which was my Milkovic oscillator. This also works quite well. Overall, I get a reasonable energy increase, but it's and the energy increase, I should say, comes from concrete, or in my case lead weights, which I forged. So that does reduce the price of the huge neodymium magnets considerably, and it's overall quite a good system. But I prefer Newman motor. Once you get the coil geometries right, it will produce good efficiency at a reasonable expense, and I suspect has a ROI, or a return of investment, at the cost of today's electricity prices, calculated 24 cents per kilowatt. I could build a Newman mode that would pay itself off in between 5 and 6 years, not accounting of course the cost of my labour. So compared to a normal motor, it's a bit of a joke, but if you were to build one as an investment, as I did, and built 3 of them, they are actually going to pay themselves off even faster than solar panels. So they are possibly not as ridiculous as it may seem. But this is of course a rich man's problem. As I said, I've been designing free energy machines for over 20 years, and in the last couple of years I've come across and built quite a few that actually work. So that is why it's a rich man's problem. We now have quite a number of options. They may not all be economically viable, in fact arguably none of them are, but they do work, they are usable, and they're almost economically viable, especially given the expected lifespan compared to a photovoltaic array, which is add a little grease to your bearing and they keep going for hundreds of years. No problem, they're arguably the best way to go. Just another word to Daniel and my fans if you sat through watching. This guy Daniel, he's built some awesome Tesla coils, 4 watts of input power through little high voltage shock circuits and flux water circuits. Daniel, get an earth rod, stick it in the ground and measure the current throughput between the earth rod and your high voltage source. The high voltage source Tesla coils suck electrons from anything they're connected to. You connect them to a glass of water, you connect them to the ground, you connect an earth rod to a tree, hold it in your hand. Either way, the high voltage source will pull electrons towards it, and you can garnish electricity from that that you didn't have to pay for. This is an open system. I wanted to explain this differential quite quickly. The systems I'm working on, i.e. the motor, the linear motor, and of course the Milkovic oscillator, well actually not the EM systems, they are closed loop. They're particularly genius because they're closed loop systems. You get more energy out than in. But the Milkovic oscillator is an open system because it will extract part of its energy from gravity. The Tesla coil will extract part of its energy from the surrounding environment in the form of electrons, just in the same way an air conditioning system transfers heat at 3 times the rate it costs to do it. These are good examples of free energy machines, some of which more readily available than others. So I hope you enjoyed the video. That's pretty much all I wanted to say. I hope you enjoy the process of building them, and Lenz Law is your friend. It makes motors run more efficiently. Don't be a hater. And if you come up with a way of getting energy more than you paid for out of a closed loop transformer, please let me know. Don't send me any more video clips of Fane Hines Regen X motors or transformers. I've seen a few out there. Look, he's a lovely guy. I adore him. So friendly. He even posts his telephone number on the internet. I've talked to him for quite some time. He's a bit secretive. We understand why. The machines don't really work. But I'd encourage you not to build those, because although they seem like closed systems that work, they do not. They do not. Actually, turn off this video if you don't want to hear why. But I did try to build one. Just briefly, what they contain is an electromagnet with a very large number of turns on the coil. Just like any generator, when the magnet approaches the coil is short-circuited, so it energizes the coil. That now has a thick flux density. When the magnet moves away, normally the coil would collapse. I'll leave it be, no problems. This time, because the flux density is so high, the magnetic field in the coil takes quite a long time to collapse. It waits till the magnet moves away and then it collapses, and then it produces an opposite magnetic field that actually pushes the magnet away. So this is what he calls regenerative acceleration. The magnet comes in, charges the coil collapses and pushes away. So if you put a Regen X coil next to a rotor full of high-speed magnets, and it's got to be very high speed for this to work, and then you short the coil, the rotor will actually increase in speed. I've seen a lot of guys doing this, all kinds of motors. They've got the motor spinning, then they short the Regen X coil, and it accelerates. Look, this is very cool. I did it. And I've seen some poor guys who built like a lot of coils and connected them all up together, and one by one, and the rotor progressively spins faster and faster, which with each coil they short circuit. And my goodness gracious me, this is a lot of wasted copper, because I hate to break it to you, but what you should do, instead of spinning your little 10,000 RPM magnets, which are going to explode and make it halfway to Mars, well, let me explain what I built. A rather large rotor, 40 centimeters diameter, give or take. So the speed of the magnets was only 3,000 RPM, fast enough to approach the coil, get past it and repel again. This requires very high speed. But I did what no sane man would do, which is have that spinning next to me whilst I actually held the Regen X coil and moved it closer to the rotor. And I built a special ramp to do this, worry not. I wanted to see it move faster as I approach it with this independent coil, and it didn't. This coil works before, but when I move it slowly towards the rotor, it actually slowed down. So all I had to do was be slightly risque to discover that this doesn't work. This is because of the drag factor of the core within the coil, which is necessary. And even when you add two cores that are connected and two Region X coils, which is basically Ed Lead Scarlin's idea, just adopted in a slightly different way, also doesn't work. It's the magnetic drawback from the iron cores. So sorry, none of these ideas seem to work, and even not in the form of transformer. I'm well positioned to say that because I've spent a lot of time in the last year working on over unity transformers, and the news is not good. I've done what, as far as I can tell, no one's managed to do before, which is squeeze 98% efficiency out of an iron transformer. Generally you struggle to get that out of a ferrite. Most commercial iron transformers push 90%, so maybe 92 if you're lucky. 93, it's just not going to happen. But due to my custom-made electronics, I managed to get 98%, which is phenomenal. I pursued this one very hard and could not touch 100%, and in doing so found sound theories and understandings as to why it can't be done. So at the moment I don't believe on the entire scope of the internet that there is actually a way of getting 100% efficiency out of a transformer, let alone 200%. So, big fan of the free energy community. I love it deeply. So much going on out there, but we're restricted to machines that aren't solid state at the moment. Thank you very much for your input. Love my fans. Thank you for the great comments. Keep building those machines. I have a huge Newman motor build on the go. Not sure when I'm going to present it. Most of it hasn't been done yet, but I do have all the parts, and I'm struggling to find a reason why not to complete it. There's a lot going on, but yeah, we're trying to find a big step forward. So please help, and yeah. Have fun, peace and love. Thank you for the company, and don't build an Adams motor, because Lenz Law helps. Lenz Law is a good thing. Lenz Law is God, but it's a regulator. You got to work on geometry. So yeah. I just got stung. Do enjoy your evening. Bye bye.